Explain like I'm 5 why we don't have 128-bit OS or CPUs. Modern x86 CPUs already have some memory and operations which work on a 128-bit base SSE and AVX extensions. It just does not make much sense or bring big advantages to use them as a general base. 64-bit addresses are enough for current memory, and 128-bit numbers are not used so often, and for the cases where you would use them you have these extensions. And 128-bit CPUs would most likely be more complex and need larger chip sizes and therefore would be more expensive and need more energy. And doing that for little to no advantage makes no much sense. I'm 5 when it comes to tech. So we'll explain as I know it. Basically it's possible and exists. There just isn't a practical reason to go beyond 64-bit for most computing needs the ability to store and use the amount of unique values a 128-bit system provides isn't necessary for home use, gaming use, or most office use. And since 128-bit would require more power and resources, it's not practical to just throw in if it isn't needed. No real need for them yet. 64-bit numbers can hold really huge numbers. And there aren't many tasks that need bigger numbers. So while 8-bit, 16-bit and 32-bit CPUs were limited and needed multiple instructions to do things, the current CPUs are capable for most things you want to do. And we have specialized GPU hardware for the things that a general-purpose CPU isn't good at. To add to the great answers here, it's a common misconception that 32-bit is faster than 16. 64 faster than 32 and so on. Yes, if software is specifically designed to take advantage of the larger integers, then yes, it's faster. If not, it's the same or slower. I'm no engineer, but I think you could build a 16-bit processors that could handle higher clock speeds than a 64-bit CPU, while running 16-bit code, that is. We do. Actually. We even have 256-bit CPUs. It's just, why would you ever use them? They're useful for some people for making extremely accurate calculations like ungodly levels of precision. But unless your field explicitly works with that level of precision, you'd never need them. Actual explain like I'm 5. The number of bits is basically a limit to how high the computer can count with one number. And the vast majority of computer work doesn't need more yet. 32-bit is just over 2 billion 9 zeros. 64-bit is over 18 quintillion 18 zeros. 128-bit is 340 undecillion 36 zeros. There is a fixed cost to more bits that you have to pay even if they are useless. It's a very, very rare circumstance where there will be any value. Easier ways to fit those needs. It's like putting a second car on the top of your car. It's a lot more money, more weight, more gas, more things to go wrong. The only advantage is if you flip your car over, you can keep on driving. But there are better and cheaper solutions to that problem. Similar reason why we had 2-digit dates until Y2K approached. 4 digits took up twice the space and we were decades away from it mattering. 128-bit CPUs would need twice the size for many things, but we're decades maybe away from hitting the current 64-bit limits. So it'd just be a waste. We have 128-bit and 256-bit GPUs where how fast we can move memory makes a big difference. Most of the comments here are about general-purpose computation where 128-bit integers don't make a lot of sense. But in special-purpose fields like cryptography, 128 and 256-bit keys are actually on the small side. I actually have a related question. Why did all of the jumps happen by doubling bits? Like, why did we go from 32 to 64? With no stops along the way? Oh, believe me, we do. It's just that it doesn't make sense to mass produce and sell the fastest technology ever invented. Until people want graphics better than Spider-Man 2 on PlayStation. Because the need to address over 18 exabytes 18 million terabytes of memory doesn't come up very frequently. It's exponential. 64-bit is a lot. Our current CPUs are still not really 64-bit. I believe most use 48-bit addressing still. It's going to take a while before we max out 64-bit. 128-bit is more than we will ever need. No, really. A perfect computer that needed 128-bit memory would boil the oceans before it could fill its memory. It is in all, we just don't need that yet. 64-bit gives far more than enough memory addresses. We upgraded from 32-bit to 64-bit, so more memory addresses could be used. It basically allows the computer to count much higher. Imagine you have a wheelbarrow full of dirt that you need to take somewhere. You could dump it into a pickup truck, or you could put it in a dump truck. The pickup truck is just fine and won't cost a lot of money to drive. The dump truck could also take the dirt, but it's way bigger than it needs to be. Fuel is very expensive, so it will cost a lot more to operate. Pickup truck is a 64-bit PC. Dump truck is a 128-bit PC. Wheelbarrow full of dirt is like the applications and files used on pretty much all systems. No one seems to have given the simplest answer. Manufacturers aren't even using all 64 bits of the word now. The bits are there, but they're just filled with essentially blanks. Actually, it's a string of all ones or zeros, based on the last used bit. To be exact, your computer using the standard x86-64 architecture only uses the low 48 bits. The top 16 bits are just a repeat of the 48th bit. I teach this class every spring.